Greetings, welcome to a video on practice problem 8 from section 7.3, characteristics of logarithmic functions. So in this particular section, it's real important that you read through the worked examples and try and make them make as much sense as possible. If there are any trouble with those, do not be shy about asking me to make videos of the worked examples. I can do those and of the U-tries. But this is a great little problem, so we'll do this one. Okay, so what they're asking for us to do here is they want us to graph g of x equals log base 2 of x on your graphing calculator, fill in the table below, and plot the points in the grid. Use these points to sketch an accurate graph. So they want you to actually plot points here. So we're going to go ahead and use our calculator's table feature to help us fill in this table. So let's get the calculator out here. So I'm going to go into our y equals, cut out all this craziness from the previous chapter here. And we want to put in logarithm base 2 of x into y1. That's the function we're working with. Well, we don't have a logarithm base 2 built directly into our calculator. We have logarithm base 10 and logarithm base e, which we'll talk about later in the next couple sections. But we don't have base 2 built in. So we use the change of base theorem, which basically what that tells us is that if I take log of x and I divide that by log of 2, that's equivalent to log base 2 of x. Okay, so that is logarithm base 2 of x. All right, cool. So now that we've got that, let's see, they want us to generate a table, and let's see, the points we want are 0.5, 1, 2, 4, and 8. So I'm going to go ahead and go into my table setup here, and I'm going to make my table start at, I don't know, let's make it start at 1. It doesn't matter because I'm going to change the auto to ask. That's the main thing here. I want to come down and I want to change this to, go back over there, I want to change this to ask on the independent. And when I do that, when I change my table to ask on the independent, it allows me to input these values and it will give me the corresponding outputs. Okay, so let's go to our table now that I've done that. And notice we're greeted with a blank table that I get to put numbers in. So I'm going to put in 0.5. I'm going to put in 1. I'm going to put in 2. I'm going to put in 4. And I'm going to put in 8. Notice they cleverly picked points that gave us nice ordered pairs. Because remember what the logarithm is asking us. What this is saying here is it's saying when I go in and I plug in, let's go ahead and do a few of these by hand here, okay? When I ask you what is the logarithm, come on you, there we go, logarithm base 2 of 8 and ask you to evaluate that, the way you want to read that in your mind is you want to say, okay, what is the exponent on a 2 that gets me 8? And you say, well, I know what that is. That's equal to 3. In other words, this is equivalent. This is the inverse operation to saying 2 raised to the third power is equal to 8. Similarly, down here with the 4, when I say, okay, what is logarithm base 2 of 4? Well, I'm asking you, what is the exponent that when I take 2 and I raise it to that exponent, I get back a 4? Well, that's going to be equal to 2, because why? Well, because 2 squared is equal to 4, isn't it, right? And when I ask you, what is logarithm base 2 of 2? Well, that's going to have to be equal to 1 because the exponent on a 2 that gets me 2 has got to be equal to a 1. Now, the last one here is a little bit trickier. Logarithm base 2 of a half, because that's what 0.5 is. Well, 2 to the negative 1 is equal to 1 over 2, so that tells me that this must be equal to negative 1. Okay, so let's go ahead and fill the table out here. So this one is negative 1. Oh, I skipped one, didn't I? My bad, sorry about that. Logarithm base 2 of 1, what's that equal to? That's got to be equal to 0 because 2 to the 0 is equal to 1, right? So the exponent on a 2 that gets me 1 has got to be equal to 0. And then that's going to be a 1, that's going to be a 2, and that's going to be a 3, okay? All right, so let's go over here and let's plot these. So we know, let's go ahead and get ourselves, let's make it in red here. Let's go ahead and make ourselves a dashed line on the y-axis here because the y-axis is acting as a vertical asymptote here. Okay, and now we come in and we plot these points. So at a half we get -1, which is right there. And then at 1 we get 0, which is right there. And at 2 we get 1, which is right there. And at 4, so 1, 2, 3, 4, we're up at 2, which is right there. And then 5, 6, 7, 8, we're at 1, 2, 3, which puts us right there. Okay, so plotting our points, and now we're going to try and do as good of a free-handed graph as I can on my little graphing tablet here. So we're going to try and go through all of these points. And we want to come down asymptotically to the y-axis. I'm not doing a very good job of making it look asymptotically, but don't let it go across the y-axis. It doesn't pass through the y-axis. Comes up to it. It's a vertical asymptote. It gets as close as you ever wanted to, but it's never going to touch it, okay? All right. So now they want us to do this again. They say graph g of x equal to logarithm base 5 of x in your graphing calculator, fill in the table below, plot the points on the grid, use the points to sketch an accurate graph. Okay. Oh, so we never actually graphed it on our graphing calculator, did we? So we should probably go back and do that just to see if when I graphed it by hand, if I did a good job or not. So let's go check this out. So let's go do a zoom and the number 6. And there you go, there's the graph. Now notice the calculator can't deal with the vertical asymptote. The closest it can get to doing that is to start the graph very close to the y-axis, but don't let it touch it. But that looks pretty much like mine, okay? Putting the arrow on the ends of it here lets you know that this is going down to -infinity here and it's heading off to +infinity over here. Okay, so this time they're asking us to change it to logarithm base 5, so let's go ahead and do that. Let's go to our y equals here, and really the only thing I have to do is change that 2 to a 5. So let's do that. Change that to a 5. All right, cool beans. Let's go ahead and drag this over here so you can see the table. They're only asking us to do 3 points this time. So let's go into our table, let it help us out here. Let's clear out any of the craziness from last time. Actually, delete is what I wanted to do, right? Delete, delete, delete. There we go, delete. Delete, there we go, much better. Okay, so I'm going to put in 0.2. Going to put in a 1. And I'm going to put in a 5. And we get back -1, 0, and a 1. Okay, so why is that again? Let's go ahead and review that. So the reason that we got those is because why? Well, logarithm, put my O in there would be better, logarithm base 5 of 0.2 is equal to logarithm base 5 of 1/5. And so what's that equal to? Well, what is the exponent of 5 that gets me 1/5? That's equal to -1. The reason is, again, is because 5 to the -1 is equal to 1/5, all right? Okay, logarithm base 5 of 1, that's going to have to be equal to 0 because why? Well, because 5 to the 0 is equal to 1. Okay, logarithm base 5 of 5, that's got to be equal to 1. Why? Well, because 5 to the first power is equal to 5, all right? Now, I know they didn't ask us to do this, but let's do it anyway. What if I had logarithm base 2 of 25? Let's try that again, Mike. Logarithm base 5 of 25, stuck on the last problem. What would that be equal to? Well, that's going to be equal to 2. Why? Well, because 5 to the second power is equal to 25. All right. Now, that you can see that's why they didn't ask us that one, because yeah, that would have to be 25 on the x-axis, and we're stopping at 10. Okay. All right. So let's go plot the points that they've given us. So at 0.2, we're at -1, so that's pretty darn close to the y-axis. And at 1, we are at 0. And at 2, 3, 4, 5, we're at 1. Okay. So again, let's go ahead and draw in our vertical axis as a vertical asymptote here. we know we cannot cross that red line of death. Okay, we don't get to go through there. So that means our function, doing my best job freehanding here, it's going to look something like that. Okay. All right, let's go take a look and see what it looks like on the calculator. See if we got a close match here. So we press graph. Yeah, sure enough, as compared to the previous graph, we see that it's down closer to the x-axis versus g of x equal logarithm base 2 of x. Okay. All right, so hopefully that helps jumpstart you with graphing of logarithms and maybe talk a little bit about what the logarithm actually is. And we'll be back here in a little bit with another problem. Okay.